Okay, so with normal distribution, instead of asking you to find the probability, what they can also do is give you a probability and ask you to find the missing value, either the x value or the mean or the standard deviation or both. And in that case, we're going to use the tables in reverse. So that means that you are going to find the probability inside the table. So remember, these values in here are our probabilities. So we're going to search in there to read the corresponding Z value. And then once we have the Z value, then we can use our standardizing equation to find what we're missing. But the important thing to remember is these graphs. Remember the area under the curve, all of that area is equal to 1, which is the same as saying that all of this is 100% of the curve. Okay, because remember, our probability can be the percentage chance that something happens. So when we're looking at percent, it's the same thing. There's 100% in here. Okay, which means, remember, it's split in the middle by the mean. So on this side, there is 50%. And on this side, there is 50%. So whenever we're dealing with using these tables in reverse, it's always really important to remember that, because if we're given a percentage probability of something, we need to always find what area on the curve is that actually taking up in order to be able to find which Z value we're looking for on the table. So if we look at some examples. So here I have one where it says, find the value of K such that the probability that X is less than K is 0.75. Okay, so 0.75, remember, if the whole thing is equal to 1, that means it's 75% of the table. So the first thing you want to do is you want to draw your graph so that we can work out if this is 0.75 and it's got to be less than. Less than means everything to the left, and it must take up 75% of that. So remember, this side, that's all 50%, which means it's going to be even more than that. So all of that is 75% of that graph. So that will tell us that this X value or K value that we're looking for is going to be on the positive side. And we are looking for everything to the left-hand side of that, because we want the probability where X is less than K, okay, which is going to be 0.75. So now what I would have normally done to solve is I would have looked, is it positive and is it going to the left? And yes, we've got a positive and our area is to the left, which means for me to find the Z value, I now look inside the table. So normally where you would have said phi and you look that up as Z, now I look at the reverse. So I say to the -1 of my 0.75. And now I go into my table, and then in here I find 0.75. So I have a look to find the closest to 0.75, that's below it. So I would say over here, which is 0.67. Okay, and now I want to get this as close to 0.75 as possible. So I can see that over here, to get 86 up to 100 to make that 75, I am missing another 14. So now I go to this side where I've said add, okay, and I try and find one that gets me as close to that as possible. So here it says add 13. So adding 13 to my 0.7486 would get me to 0.7499. which is as close as possible without going over. If I went to one up, I would then be over. So I can say that my value is 0.674 to get there. So now that means that my Z value is 0.674. Okay, and what I normally would have done to standardize is we would have had our value minus the mean over the standard deviation equals your Z value. So I'm missing K. Okay, I still have the mean because this always follows on from a previous question, and the previous question told me what the mean was and the standard deviation, which I can then sub in. And equal it to my Z value. And then all I have to do is now solve for K. So if I take that to that side and then move that over, I end up with K equals to my value. Okay, so if I look at another example, as I said, remember questions always follow on from the other one. So here we already worked out the probability for the swimmers. Okay, but now our second part of it says 13% of the members of the club take more than T minutes to swim 100 meters. Find the value of T. Okay, so now remember, we were given the time taken to swim 100 meters with the mean of 62 seconds and a standard deviation of 5 seconds. But now I'm asked for the time in minutes. So the first thing I'm going to do is find the time in seconds, and then I can convert it to minutes. Okay, so I know that I am dealing with 13% of the members taking more than T minutes. So that means that I'm dealing with an X variable taking more than T. And I'm told it's 13%, so that is 0.13. So first thing I'm going to do, draw my curve, okay, and remember this is 100%. So now where it's more than is always going to mean everything going this way. It's going to be to the right because it's everything higher. But it's only 13%. So if this entire curve is 100 and I want everything higher, it means I only want the top 13% because I want everything more than, but this is only 13%, which is quite small in comparison to the 100. So this is what I'm looking for, that area over there. So now I know what I normally would have done, because this is now to the right, even though it's positive, is I would have said 1 minus to get rid of everything to the left. So now when I want to get my Z value, I still need to say 1 minus 0.13, because this is how I normally would have solved for my curve. Okay, and that would have given me a value of 0.87. So now for my Z value, I am looking inside my table, so I'm looking for the reverse of my 0.87. So now on the table that I have, on the inside of it, I'm going to look for 0.87. And I'm going to see there, I always go for the one below. Okay, so that's 1.1, 2. And now I want to get this value as close to 0.87 as possible. So then I look in my last column for a number that I can add to get this to 0.87. So 86, I need 14 more to get that to be 100 to be 0.8700. So 14 more would be 0.7. So I've got 1.127 would give me my perfect number. So that means that then my Z value is 1.127. And now I need to use the equation that I normally would to standardize. So I would have said my value minus my mean over my standard deviation to equal my z value. And then I just sub in the numbers. So the mean was 62 seconds over 5 seconds equals 1.127. Then I solve for t, and I end up with t giving me 73. But remember, that's seconds. So now, since I wanted it in minutes, all I have to do is divide that by 60, because there's 60 seconds in a minute, to get my final value in minutes for my answer. Okay, so then another example. Okay, so before I looked at the trees and I calculated the probability of getting a short tree. Okay, so now if I'm told that of the trees classified as tall or medium, 1/3 are tall and 2/3 are medium, and then you had to show the probability that the random chosen tree was classified as tall. Okay, corrected 3 decimal places. So if this is the probability of having short, okay, I can say 1 minus that is going to give me my answer for everything that is medium and tall. Okay, so now that's the combined for medium and tall, and we've said 1/3 is tall and 2/3 is medium. So if I took that and divided it by 3, that would give me the proportions for 1/3 each of the tall and the medium. And when you divide that by 3, you get 0.298, which is what they wanted us to show. But now I have the proportion that is tall. Okay, so then the next question now says that find the height for which they are classified as tall. So I've just said the proportion that's tall. Okay, so now I can use that to find the height, because I want the probability for my x value when they're tall, which means when they're going to be greater than a specific value of my x, because if they're tall, it means they're in the top bit. So they've got to be taller than a certain amount. Okay, and my probability is 0.298, because that's what I just worked out. So now that I know that, I can draw my curve. Okay, and 0.298 is 29.8% of the curve, or 30% of the curve. And since it's greater than, I know I want everything to that side of the curve, because it's now going to be the top bit. So 30% is going to be up to there, because remember, it's only the top 50% there and 50% there. So 30% is just that top bit there. So now I know that my value is going to be in the positive side. And I'm looking for an area that is to the right. So what I normally would have done to solve for my curve, okay, since I want to eliminate the area to the left, I would have said 1 minus my value. So now I'm going to look for the inverse of 1 minus 0.298, which is 0.702. So now I know what I'm looking for in the table to find z. So in the table, I now look for 0.702. So my closest thing that I can get to, since I want 0.702, so 0.7019. Okay, if I looked on this side, the smallest number I can add is 3, so then I would be too high. So this is the closest value I can get, which is 0.53. So my z value is 0.53. Okay, so now I have the z. So what I normally would have said is x minus the mean over the standard deviation to get my z value. So that's x minus the mean, which I was told previously in the question, with a mean of 40 and a standard deviation of 12. So now I say x minus 40 divided by 12 to equal my z of 0.53. And then I can solve for x to give me my value for the minimum amount that they can be that tall. Okay, so that is using probability to solve for an x value or unknown value. But I also said here I can use it to solve for mean, standard deviation, or both. So if I look at an example now where I need to now solve for those, we're going to do pretty similar, okay, because we've got a mean given to us now this time, and we're told 22% of these have a weight greater than 87. So that's an x value. There's a percentage and there's a mean, and now I need to find the standard deviation, okay, dealing with these weights of apples. So first thing I'm going to do is write down my x value, because I want the probability that x is greater than 87. So that means x is going to be greater than 87. Okay, and the proportion of those is 22%. So I know that that is 0.22 in probability. Okay, so now that I know that, I can draw my curve. And I want 22% of that curve for being greater than. So greater than means it's going to go to the right, and it's only 22%. So it's only everything there. So now I know, since this is the curve, what I normally would have done is said 1 minus. So to get my z value, it's 1 minus my 0.22. So now I am looking on my table in reverse for 0.78. So now I look in the table and I find the closest thing to 0.78 that I can get. So 0.7 and then 7. And then I look, what can I add in order to get that to 0.78? Okay, and since I am missing 6, because that's 94, okay, I can see that by adding 6, that means 2. So I've got 0.772 for my answer. Okay, and now I have the z. What I normally would have done to standardize is I would have said x minus the mean over the standard deviation equals z. So the x is 87 minus the mean, I'm told, is 82 over the standard deviation equals the z value of 0.772. So now I can solve for the standard deviation. So in order to solve for the standard deviation, okay, I can switch those around. 87 minus 82 works out to 5. Okay, and if I swap those two, it means over 0.772 equals the standard deviation. So that means that my standard deviation works out to 6.476. Okay, so now they can sometimes start with a question like this because I had to work out the standard deviation. And then, now that I have it, then it can follow on to finding the probability that the weight of the randomly chosen apple differs from the mean by less than 4 grams. Okay, so that means that we want our value for x, it's going to differ by less than 4 grams, which means it's got to be greater than my mean value of 82 minus 4, and it's going to be less than 82 plus 4 for that, because it's got to differ by less than 4 grams, which means then I can do exactly what I normally would have done and standardize the variables, minusing the mean over the standard deviation that I just worked out to get my Z value. And I will end up with a Z value okay, and now I can see that those two values are the same, but one is negative and one is positive. Okay, so remember, if I draw the curve, it's going to mean that I want everything in between. But when they're both the same, I know that I'm going to say 2 times my phi value of my table of 0.6176 minus 1. Okay, remember, it's going to be 2 times my value minus 1. And then I'm going to look at 0.6176. Okay, now remember, I'm finding the probability. So remember, that's the Z now. So I'm going to look for 0.61, and then 76 can round off to 8 to mean I'm going to add 26 to my 91 over there to end up with 0.7317. So I'm going to say 2 times 0.7317 minus 1. Okay, and if I work that in my calculator, I get 0.463. Okay, so now just don't get confused about when I'm using a percentage to find a Z value and I'm looking inside the table, or when I'm finding probability and I'm looking outside its Z to find inside the table. Okay, so then if I look at another example now to find my standard deviation, okay, I have the weight of adult male giraffes normally distributed with a mean of 1,190 and a standard deviation that we don't know. But I'm given that 83.4% of the male giraffes weigh more than 950, and I need to find the standard deviation. So I've got the probability for X being more than 950, and that is 83.4%, which is 0.834. Okay, so now I know what I've got. I can draw my curve. But the curve is saying for everything that's more than, which means I know I'm going in that direction to the right. But it's 83% of the curve. So remember, this is 100. So 83%, this side is 50. So that means I need more than that to be 83%. So I need everything to that way. So since I need so much of the curve, and remember that was 0, this on this side has to be negative to make up that percentage of the curve. So now I am looking for a negative Z value, okay? And since this is on the negative side, what we normally would have done is flipped our curve to solve. And if we flipped it, we would have got everything there, which then meets our criteria. So now we are looking for the inverse of that value as it is, because that's how we would have solved the curve. So now my Z value, which is still negative, I look up my 0.34 in the table that I'm looking for. So I'm looking for 0.834, which is 0.97, because there's my value right there. So I've got 0.97. But now remember, that is a negative value. So the Z is negative 0.97. Okay, so now I would have normally solved by saying X minus the mean over the standard deviation equals Z. So the X value is 950 minus the mean is 1190 over the standard deviation is going to equal my Z value of negative 0.97. Okay, and now I have to solve for my standard deviation. So I'm going to switch those places. Okay, to have my 950 minus 1190 divided by negative 0.97 equals my standard deviation. And I end up with a standard deviation value of 247. Okay, so it's super important that you always remember where it's going to be negative, though, because that can affect your equation. Sometimes if I have to add or subtract, but I've used the wrong sign, it's going to mean that I'm going to do the wrong number. Okay, so that's always the important thing to remember about the curve being a total of 100%. So if we look at this last example, now this time you have to find the mean and the standard deviation. They're both missing. So our information says, the length of the male snakes in this species also have a normal distribution. A scientist measured the lengths of a random sample of 200 male snakes in the species, and he finds that 32 have lengths less than 45 and 17 have lengths more than 56. So I have got that for my X value, 32 of them have lengths less than 45. So that is less than 45. And now 32 of them out of 200 can give me the proportion. So I can say 32 divided by 200 is going to give me 0.16. So 16% of them have lengths less than that. Okay, so now I can do what I normally would have done. Since I now have a variable with the proportion, I can draw my curve. Okay, and I am dealing with less than. And since I've got less than, that means I want everything smaller, so to the left. And it's only 16% of the curve. So 16% is quite a little bit on there. So that means I'm going to fall on the negative side. So now when I'm looking for my Z value, okay, it's going to be a negative. And now what I normally would have done to solve this curve is I would have flipped it over. And now I'm looking for that side. So now I would have said 1 minus to get rid of all of that. So I can say that my Z value is going to be 1 minus my 0.16. So my negative Z, I am looking for the inverse of 0.84 on the table. So now I look that up with my table. I find 0.84, and I can find the closest value I get is there, so 0.99. And now I look what I can have to make that as close to 0.84 as possible. I would say add 10, so that's a 4. So my final answer for my Z value is 0.994. But remember, that's a negative Z, so then Z is going to be negative 0.994. So now, remember, that gives me one equation, because now I would have said my X value of 45 minus the mean over the standard deviation equals to that Z. So there I have one equation. Okay, now my second bit of information said I have 17 that have lengths more than 56. So that's the probability that x is now more than 56. Okay, and that is 17 of them. So I can say 17 out of 200 is going to give me a percentage of 0.085, which is 8.5%. So now I know I can draw my curve, and I have more than, which means now I want everything to the right, and it's only 8%. So that means it's going to be 8% at the top. So it's going to be there. So now I know that that's a positive z value, and what I normally would have done to solve my curve is say 1 minus my 0.085. So now I am looking for the inverse for 0.915. So now I look on my table, I find 0.915. So I find where I have my closest value of 1.37, and what I can add to get that to 5 is a 3. So there's my last number. So now I have my z value as 1.372. And I would have said 56 minus the mean over the standard deviation equals my z value. So now I have two equations. So I can make one of them one unknown variable the subject of the formula, and then I can sub it into the other. So if I wanted to make the mean the subject of this formula, I can say 56 minus the mean equals 1.372 times the standard deviation. Okay, switch those positions and I get 56 minus 1.372 standard deviation equals mean. And now I can take this and sub it into there to solve for my standard deviation. So if I do that, I can say 45 minus that 56 minus 1.372 standard deviation over the standard deviation to equal my negative 0.994. And now I can just solve for that unknown. So I take that to that side, multiply in the negative, and I will eventually get my theta by itself as 4.65. And now that I have that, I can sub it back into any one of my equations to find my standard deviation. So if I sub it back in here, I can get 56 minus, it's easy to use this equation, so I say 56 minus 1.372 times my 4.65 equals the mean, and that gives me a mean of my 49.6. So even though we've got two unknowns, you just make two equations with the information you're given, and then you use one to solve for one unknown variable, and then you can sub it in for the other. So no matter what is missing, as long as we have given some kind of information to work out probabilities, we can then read the z values off the table and use them in equations.